All right, number 3, we want to test the hypothesis using the p-value approach, and then we want to be sure to verify requirements of the test. So regardless if they ask you, you want to make sure that you can use this method. So since we're doing the population proportion, the two things we have to check is that n times p times 1 minus p, this number needs to be greater than or equal to 10. And then we also have to check that n is small, so less than 0.05, so 5% of the entire population. So these are the things we want to check. So we are given that p is 0.8, so this would be the sample size. Let me do n first. N is 125 times p, which would be 0.8, times 1 minus p, so 1 minus 0.8 would be 0.2. So we would multiply and check those, see that that is greater than 10. Pull up this calculator. So we're going to do 125 times 0.8 times 0.2. And we get 20, that's bigger than 10. And we do not know what the sample is drawn from. We're not given any information. So we're just going to have to assume that it's independent. It doesn't tell us. But from there, we want to calculate the test statistic, and then we're going to do the p-value approach. So let me explain that, and then we're going to do it with technology. So when we do the p-value approach, remember, the bigger p is, the weaker the evidence. We're told we want to test this at alpha equals 10%. So we want 10%, we're going to reject. So what this means, this is alpha. This is our acceptable number, which means we want this area to the left. This is 90%. We want to be sure with 90% accuracy. Normally we do smaller. So if we find out that there's a 10% or less chance, so if my p-value is less than alpha, we reject the null. That means there's really strong evidence against the null, because we assume the null is true. So if we fall in this area, we call this rejection region. If we're 10% or less, that something will happen when it should happen 90% of the time, but we find out it falls over here, we're going to reject the null. So using the Z statistic, this is the test statistic, we would be using the p hat minus p divided by the standard deviation, which is square root of p times 1 minus p divided by n. So we could do that, compute this Z test statistic, but we're going to let StatCrunch do that for us. So we're going to do StatCrunch. We are going to go to, move this over so I can see everything. Stat, we're going to go to proportion, one sample summary, because we don't have the data. Number of successes, so that is our X. How many times it happened? Specific characteristic, 105. Number of observation, there was 125. We want to do the p-value approach, so we're not going to do confidence interval. We're going to do hypothesis test. Now this is saying alpha is 0.1. So my level of significance, well, I guess I need to figure out, let me do the test first. So we are testing 0.8 here, and we want greater than, so I'm going to change this to greater than. I'm going to find a critical value. So since, remember, alpha is 10%, in my drawing I said the other part is 90%, and so that's what we are saying, that's our level of significance. So right here, no, This is my alpha here, 10%. So that's what I want to change to 10%. So if I was doing confidence interval, then I would change that to 90. But this alpha is my level of significance. So we're going to compute, and this gives me everything I need. So the test statistic would be the z-stat, which would be computed using this formula. So they've done it for me once I put the numbers in. So to 2 decimal places, we get 1.118. That 8 will round up to 1.12. So 1.12. Okay, so the p-value associated with that is given here. So that's 0.13. So according to my drawing, this is 10% to the right. I've gotten a p-value right here that associates with 0.13. So 13 is bigger than 10, which means we have a weak argument against the null. So this is weak evidence. It's not over here, which will be strong evidence. So 0.13, they tell us that we want to round to 3 decimal places. So 0.132. And then we're going to choose the correct results for the hypothesis test using the p-value. So since our evidence is weak, there's not enough evidence to convict this person. So we're going to assume he's innocent. Now, if we fail in this area, less than this 10%, we would reject the null. Since we didn't, we're outside of that region, we're not going to. We're going to fail because we don't have enough evidence. So we're going, so out of our options, we do not reject the null because p-value is less. No, we do not reject the null because p-value is greater. So D.